everybody, and welcome to Dodge Deception with Critical Appraisal. This is the first part of our research workshop series on the horrors of bad research. We will use this series to discuss different problems and pitfalls in biomedical literature and methodologies. And Lauren, if you wouldn't mind advancing to the next slide. While we take the time to introduce ourselves, you can go ahead, if you're so inclined, and use this QR code to open up the slides so you can click any links or interact with the slides should you be interested in that. I am Rebecca Morgan. I'm one of the health sciences librarians here at the MCL, and I work closely with the colleges of dentistry and pharmacy. Lauren, if you want to come live and introduce yourself as well.
Yeah, my name is Lauren Robinson. I am the Associate Director of Research Services here at the Medical Center Library, and I work closely with the College of Medicine.
And you can go ahead. All right, and today we are going to open our Horrors of Bad Research series, and we're really going to talk about the scope of quote unquote bad research, whether it's large scale deception or smaller scale spinning of results. These problems in biomedical research really are everywhere, and unfortunately they are impacting clinical practice. And we are going to hopefully have you leave this presentation at the end with some tools that will help you be better prepared to deal with these issues and dodge the deception, as in the title of this presentation, through critical appraisal. So the title and theme of this presentation is The Horrors of Bad Research, which is meant to be slightly in jest, or at least exaggerated. It's a play on like when good research goes bad, and horror and spooky themes related to the month of October. So when we talk about bad research itself, like objectively bad research, is really fairly small. It's the truly fraudulent, bad, deceptive, problematic stuff that is actively trying to mislead people. We would argue that most of the problems with biomedical research is actually what we would call flawed research. And that's more the spinning of research, so taking data that is not necessarily intentionally misleading, but maybe beautifying it and trying to make it look a little better than it is, or innocent mistakes, or just not doing the research as well as it could because you're misinformed about the methodologies. This is the flawed research that makes up probably the majority of the problems in biomedical research. These are all still big problems in biomedical research, and they're causing a lot of problems, but they're not necessarily bad. They're not the horrors that are misleading things like the actual fraud. And you can really break it down into two different categories: the active deceptions, which are the fraudulent research, and the spinning, because spinning is fraudulent. It is taking data that is maybe not quite as good as people want it to be and spinning it to make it look a little better, saying, oh, it's a little stronger than the results should be. And then the mistakes and the misinformed, which are more the intentional, non-deceptive results. We're going to get into each one of these four categories of flawed and bad research and talk about them a little more in detail. And then Lauren's going to jump in after I finish that and talk more about critical appraisal. Okay, so let's talk about actual fraudulent research. And as I said, this is the knowingly misleading and falsifying of evidence. It's actually very hard to prove fraud in biomedical research because the access to original raw data and images is almost impossible to access. This is one reason the NIH data sharing policies are so important, the new ones that just came out 2023, 2024. And it's also why good data management practices are critical, because with this data being available, you will be able to prove that you did not commit fraud, first of all. And two, you will be able to go back and check and make sure that the data is sound and that fraud is not being committed. Lauren, you can move ahead. Let's talk about a real world, truly horrific example of fraudulent research that has serious real world complications. This is an example that you may have heard about where a landmark Alzheimer's research paper was finally retracted after 2 years for containing doctored images. So the authors of the foundational 2006 Alzheimer's paper that linked amyloid proteins to memory loss were finally retracted after signs of, as you can see here, excessive manipulation, including the splicing, duplication, and use of an eraser tool on images, particularly on Western blot images, was essentially as proven as can be proven without the original data being available. What's really scary is that this paper was the foundation of the basis of the majority of modern Alzheimer's treatments. And before it had been retracted, it had been cited almost 2,500 times. And from the time of publication, the annual NIH support for studies labeled amyloid, oligomer, everything related to this study rose from practically zero to almost 287 million by 2021, despite the fact it was almost impossible for researchers to replicate results. And that's a really important point, because while the authors of this study had been able to replicate their results repeatedly and published multiple papers proving these results over and over again, many other labs had failed to find the same protein in their own Alzheimer's research in their own labs. But those results, those failed results, never got published. And why is that? And it's because, and I'm actually quoting an article from Science magazine that was written on this scandal as I say this, and I quote, "Journals are often uninterested in negative results, and researchers can be reluctant to contradict a famous investigator." And so fraud that gives answers people want to hear or confirms something people want to find, like in this case, the fact that, oh, there's a plaque, there's this protein that answers why Alzheimer's happens. It's allowed to be perpetrated for decades, and millions of dollars is allowed to be spent on it, public dollars from the NIH, and money is able to be diverted away from potentially beneficial treatments that could benefit thousands of peoples, all based on this fraudulent research. And that impacts real people's lives. And that's really a terrifying research horror story. And it's all because the way, in large part, our system is set up where false or negative results are not often published, or our journals will not publish contradictory results. And that's a really scary thought. So let's move on to spinning. Spinning, as I said before, is the beautification or distortion of study results that can lead to erroneous conclusions about the effectiveness of interventions. So basically, it's leading to strongly inappropriate claims or recommendations for clinical practice, selective reporting, or more favorable data presentation. So if you have somewhat murky results, maybe your results showed a slight bias towards a result being favorable, and then the results or the conclusions of the paper says, oh, this study strongly favors that this treatment goes forward. Lauren, you can move forward. And actually, you can see that if you do look at these slides, all these images of the articles are actually linked directly if you want to read the literature that we have included in here. And studies have shown that the top 5 medical journals are not free from spin. In fact, 94% of abstracts and 67% of full text presented at least one item in spin. in these 5 journals. And the most prevalent type of spin included the selective reporting of harm outcomes. So they just diminished the type of harm that was reported. And why are people spinning results? It's kind of what we talked about before. It's the fact that lukewarm results or negative results just aren't strong enough to get published in many cases. So spin them slightly to make them possible or to make them positive. And a lot of that comes from the pressure to publish or perish. If you're not able to publish, you're not going to be able to advance in your career. And so, okay, it is deception. It's not outright fraudulent, but spin your results slightly, make it more positive, and guarantee that you can get that article published. And in some cases, spinning isn't always intentional. There can be a lack of understanding of how to interpret the data correctly. And so spinning sometimes is mixed with some of the other types of bad research, misinformation, mistakes. And so it becomes kind of a complicated, thorny problem all mixed together. Mistakes is also, or the idea of mistakes in biomedical literature is also kind of a true gray area in itself, because it's very hard to say what is actually an innocent mistake and what is actually deception. Poor data management can lead to mistakes that at best lead to a retraction and at worst lead to accusations of fraud. I don't know how well you can see this image to the right. It is, I don't know if you heard about the big Dana-Farber cancer scandal where they had to retract a very large number of studies due to issues with their data reporting for many of their studies, a lot of it to do with images. As you can see, there's that little red arrow that is going between 2 of the pictures between day 1 and day 16 of the mice, the one in the top left and the one in the bottom center. And it's because they used a duplicate image of the same mice. They claim that this is a mistake. More investigations into more of the studies done by these researchers seem to indicate that this is actually more of a fraudulent case than actually mistakes. But again, it's very hard to prove. But there are plenty of cases where a lot of the errors are actually true mistakes. And Lauren, if you go to the next page. One of these is arguably based around the first article that really arguably tried to prove the Mediterranean diet was a truly beneficial heart-healthy diet. This is a major study in the New England Journal of Medicine that ultimately had to be retracted and then republished as a lesser as an article that used less strong language later. And it was because it was determined that 14% of the 7,400 participants weren't actually randomized properly. And some of the errors in randomization were because couples that were given the different diets were just given the same diets instead of actually being randomized. In one case, a researcher gave people in the same small town all the same diet instead of randomizing them in that town. So as a result, the randomization was not proper, so they had to soften the language, and they couldn't claim that there was true blinding or randomization in this article. But before retraction, again, this had been very widespread, almost 1,700 citations before the point of retraction. And that is, again, a huge impact before already in the literature before it's had to be pulled back and changed. And that's a big problem. You can move forward, Lauren. Misinformation, when we're talking about this, when we're talking about the researcher being unprepared or untrained in the methodology to the point that they're not really ready to complete the study. And this is a huge problem in systematic reviews. And Lauren, in her part of this presentation, will discuss that in a little more detail. Another issue with this is review boards are just unfamiliar with a lot of research methods, and they're unable to identify mistakes and problems with manuscripts as they come through peer review. Again, this is another problem that we, at least as librarians, are seeing in systematic reviews and evidence syntheses and other types of advanced reviews. And it's also getting easier and easier to publish in low quality journals and publish some of these poorly constructed articles because there just are more journals to publish in. And with the push to publish or perish, it can be enticing to churn out research and publish it wherever it can go in some cases, rather than aiming for the highest quality standards. And so just to wrap it up, at least my part of it, this slide just kind of represents the thorny knot that is at the heart of all of this bad or flawed research. All these problems lead to all these errors. The fact that positive results are favored over negative results that could prove that there are issues. The fact that there's poor peer review consistency, the fact that there's a push to publish or perish, the fact that there are an increase of low quality novels. So it's really worth asking when you're reading the literature, is it too good to be true? It's worth being a skeptic. And it's important to remember that the examples we just gave are only a fraction of what's out there. There's so much that hasn't even been discovered yet, mistakes and problems. And so it's really important that you learn to critically appraise the literature. And Lauren is going to take over that part of the lecture.
Yeah. And did you have something you wanted to add to this slide as well, Becky?
No, you can
Okay.
go.
So there's been a huge increase of the amount of research since COVID. So I know I know all the medical librarians that I work with really saw a huge increase in requests for systematic reviews and other types of research methodologies that we help with during COVID. Like we were overwhelmed by the sheer volume, and that's just increased. So like when labs and schools shut down, when doctors' offices were shut down, people decided to like do that. That gave them some time to do research. And also another part of that is articles on COVID were rushed through publication. So we've seen more and more issues with that are coming out. And then it leads to quality concerns again, right? As you can see, 440 have been retracted and 18 marked with expressions of concern from Retraction Watch. So I really like this image on the right. It really shows that cascade of how many things were published and added. We already had a huge amount being added to PubMed every single day, and it just really exploded after and during COVID. So how can you dodge the deception? So we recommend using critical appraisal, and a lot of people use this during their methods for doing systematic reviews, but you can use tools for critical appraisal through when just evaluating a study. A lot of them are really nice checklists and really easy to go through and just help you know what to look for in an article. So what is critical appraisal, just in case you don't know? It's a systematic evaluation of clinical research papers. It helps to establish if the study has a clearly focused question. Does it have a valid method that it actually addresses the question? Does the method really help you answer the question they're trying to ask? Are the results valid? And then are they applicable to your own patient or population? If your answer is no to any of these, then the research is likely flawed. But how do you know that? How do you determine that? There's a bunch of tools for appraisal. These are all clickable. And there's different tools for different types of research studies. So there's just not one tool for appraisal to answer every single type of study, right? So for example, AmStar is a really popular checklist for librarians because it helps you evaluate systematic reviews and other evidence syntheses. So that one's just for systematic reviews, while GRADE is more of like reporting an outcome, like being able to evaluate outcomes of studies. There's other ones that are just for RCTs. So there's a bunch of different types of these checklists and appraisal tools based off what type of question or what type of paper you're reviewing. And JBI, and Oxford Center both have a bunch of checklists. Those are really great tools just to have a list of all different types of study checklists. So they have an RCT one, they have an observational study one, and they have other ones like that. So these again are clickable. As your medical librarians, we're always happy to help you find an appraisal tool if you're having trouble finding one for the study you're looking at. But these are just really great and easy to use in our opinion. Okay, So we're going to do some activities here if you all are willing to participate. So this one is a systematic review appraisal. So we're going to open up a poll here in just a moment. But so I actually had a student meet with me and bring me this study, and they were trying to replicate this study, or in some ways, it wasn't exactly the same. You're not supposed to do systematic reviews that have already been done unless there's a reason for it. So with the search strategy, they say that it was, they search PubMed, Web of Science, Cochrane Library, and ProQuest dissertations and theses. They give the date of January 7, 2020. They say they have a reference list, and existing systematic reviews and meta-analysis were also hand searched and included. And then they looked at clinicaltrials.gov, and then they provide a search string. And this search string has postpartum depression, postnatal depression, maternal depression, and then it has some telemedicine terms, and then has postpartum women terms. And we don't know what database this is from, but they did provide a search strategy. So the question, and the poll should pop up, did the review authors, do you think that they built a comprehensive literature search strategy? And I'll just give it a few seconds for people to answer. Okay, we can end that poll. Do I do that, Kayla? So I can, okay, I'm gonna share results. Oh, the poll's open. Okay. Well, so I don't think you all can see the poll. There's something going on with that. But so I had one person say yes, and I had 3 say no. So let's kind of go over that process and see why, or what the answer is. So inside of the Amstar, so I'm going to use Amstar for this one. Like I said, I really like this appraisal tool. It's an online website that you can actually just click on this page and go to, and you can click, like, these are actual check boxes that you can click, and it helps you appraise it. It's really handy for systematic reviews. So they actually have a question: did the review authors use a comprehensive literature search? So did they search at least 2 databases? You could say yes to that. Did they provide a keyword or search strategy? They did. And then did they justify publication restrictions? In this part they didn't, but they might have in the original article. So if yes, did they provide a list of included studies? Did they have the trials or the study registries? They did do that, which is a yes. Included consulted content experts in the field. They did not include a librarian on that search team. So that could be a yes or no, depending on if you have someone with expertise to search for in several different type of databases. And they did complete it within 24 months. So in some way, yes, but I want to kind of show you some other pieces to it. I would say no as a librarian. I would say that they did not really complete a comprehensive search strategy. And if you go to the Amstar list, you'll see a lot more stuff on there about the Amstar, or about the systematic review search strategy. Like, they didn't say whether it was appraised by a peer. So there is a new requirement for search strings to be pressed, which is a type A of appraisal for search strategies. It's a peer review process, and it needs to be done by librarians. Another thing, I would say that the search is not comprehensive because it doesn't tell you what database it was from, which is required. And also the coverage of the database is required. And then also they didn't use subject headings or keywords, and they didn't reduce bias in their search. And the appraisal tools do walk you through some of those things, and they link to things like Prisma searching extension, which is a fairly new addition to the Prisma list of checklists. So I would say no. And this is one of the big issues with systematic reviews, is because they often look like they're methodologically sound, but when you start breaking down a checklist from Prisma or checklist from Amstar, they quickly fall apart. Just because there's been brand new standards released to make things more reproducible. And even now, all of our librarians actually submit our search strategies as data to a data repository. So they are reusable, citable, have DOIs. So if anyone wanted to update or do a similar search, they would have that information available with what databases was searched, what time frame was searched, what was the search strategy, all of that would be there. Okay. So let's do an RCT one as well. So this is a study that we use a lot when we're teaching, like in journal clubs, or I'm teaching graduate students in library school to learn about evidence-based practice. So I'm just going to read this really quick, and then we'll have another poll that can be open. So from October 31st, 2000 to July 25th, 2001, 61 patients were enrolled in the study. 9 patients, 3 from the duct tape group and 6 from the cryotherapy group, were not available for follow-up and were not included in our analysis. 1 patient enrolled in the duct tape arm was lost to the study because he had a toe amputation. Of the 51 patients completing the study, 25 were in the cryotherapy arm. Oh, and let me just say, this is about wart, like duct tape versus cryotherapy. And 26 were in the duct tape arm. So that looks fairly even, right? There are no statistically significant differences in the mean age or sex of the patients, or the baseline size of the warts between the 2 groups. The most common location for the warts was on the finger in both groups, and there were no differences in the physical distribution of warts between the 2 groups. So given that, what is the question? What is the question I'm asking? So do you all see that there are issues with this randomization or any other parts of this reporting? Give it a few more seconds. Okay, I'm going to hit the end poll and we'll see if it pops up. Maybe it might share results this time. So as you can see, I'm hoping you can see that there were 2 that said yes and 1 that said no. So let's get into that and see what tool we could use. So RCTs are usually the type of study a lot of people are used to analyzing. But in this example, we're going to talk about the Oxford Center for EBM, so evidence-based medicine. This is their RCT appraisal checklist. It's very similar to that AmStar one. It gives you examples, like were all patients who entered the trial accounted for, and were they analyzed in the groups to which they were randomized. So you can say yes, no, or was it unclear? And it gives you some detail here if the loss of follow-up was more than 20%, then that's an issue. And it could see, like, it talks more about randomization. So it really walks you through what to look for when breaking down a study. You don't have to memorize everything you need to look for every study. These checklists are a great tool to not have to do that. So in this example, you can see that the loss of follow-up was 16%, but it was not, like, so it did meet that standard. The only thing was that in worst case scenario, with all 6 of the cryotherapy patients and 4 of the duct tape patients, and they had full resolution, the difference in the results would no longer be statistically significant. And these checklists would help you figure that out. So that's just another example of a tool that you can use. So our conclusions: flawed research is everywhere, and it comes in different forms, ranging from outright fraud to simple mistakes or misinterpretations. These tools that we've gone over, as well as the ones we listed, can help you become a better, more informed consumer of research, because there's always going to be flawed research, and you just have to be better at being able to sift through it. And you are obligated to use these tools with systematic reviews and evidence syntheses, of course, but they can also be used to help you or your students learn how to properly appraise a biomedical piece of literature. Okay, and then up next, we do have some more workshop series coming up. You can click on these links to see what those are, but in particular, we want to highlight 2 upcoming ones that Becky and I are presenting on. We have the Growing Systematic Review Monster. So that whole presentation is going to be about, like, why systematic reviews are the gold standard and some of the problems with the methodology today. And then we're going to talk about artificial intelligence and some of the issues that it's bringing, and some of even the benefits it's bringing to research. So those are available here, and you can register. You can also just pop into the Zoom meeting if you just want to come in. We now have some time for questions. There's going to be a follow-up email with the slides and links to the workshop series and the recording. We also have a survey. Please complete the survey if you have time. If this was useful, or if there's other sessions you'd like to see in the future, we'd be happy to do those. So thank you, and we'll stay on for a little while to answer any questions people have.